Hello everyone, I'm Varshanjali studying biotech in KL University. I'm here to discuss an instrument that is relevant to my topic. Let's go. Pitot Tube, a pressure measurement instrument. Pitot Tube is a device that consists of a tube having a sharp right angle bend which is placed vertically in a moving body of fluid with the mouth of the bent part directed upstream and that is used with a manometer to measure the velocity of fluid. Let's discuss in a brief way. Introduction of Pitot tube. It is invented by French scientist Henri Pitot in early 18th century and was modified into modern way by French scientist Henri Darcy in the mid 19th century. It is widely used to determine the airspeed of an aircraft, water speed of a boat, and to measure liquid, air, and gas velocities in industrial applications. The pitot tube is used to measure the local velocity at a given point in the flow stream and not the average velocity in the pipe or conduit. And here is the diagram of pitot tube. Here PT is the total pressure and PS is the static pressure. And this is the pressure transducer. Let's discuss the types of the pitot tube. There are three types of pitot tubes. Simple pitot tube, static source, pitot static tube. Here, simple pitot tube is used to measure the velocity of flowing fluid and total pressure. And the static source is used to measure the flow velocity of liquid along the pipe. Pitot static tube, it consists of pitot tube and a static tube and that measures pressure in such a way that the relative speed of a fluid can be determined. And the construction of Pitot tube. Pitot tube actually consists of two hollow tubes that measure pressure at various places within the pipe. One tube gauges the impact of stagnation pressure, whereas the other tube measures only the static pressure, usually at the pipe wall. These hollow tubes can be mounted separately in a pipe or installed together in one casing as a single device. And the working principle. The Pitot tube meter comprises a tube that is directed towards the flow. The fluid penetrates through the impact hole, and apart from this, there can be two more holes in the Pitot tube that act as static pressure sources, as we discussed in the above slides. The Pitot tube installed in the flow stream measures the directed pressure at the contact Pitot tube hole, and the second measurement is required, being of static pressure. Difference between the two measurements gives a value for dynamic pressure. The flow rate, like other devices, is calculated from the square root extractor of the pressure. In phytostatic tube, Q is equal to K root Ps minus Pi, whereas K is a constant, Ps is the static pressure, Pi is the impact pressure. And let's discuss how Pitot tube works actually. Actually, a pitot tube is simply a small cylindrical that faces a fluid so that the fluid can enter it. Because the cylinder is open on one side and closes on the other side, fluid entering it cannot flow any further and comes to a rest inside, separates the incoming pressure from the stagnation pressure. Here, incoming pressure is the static pressure and stagnation pressure is the total pressure of the system. Difference between these two instruments determines the fluid's rate of flow. Derivation. Here P1 minus rho g is the pressure head at 1 which is equals to capital H. P2 minus rho g is equal to pressure head at 2 that is equals to small h plus capital H. But here Z1 is equal to Z2 and the V2 is equal to 0. Substituting these values in the above equation, we can get capital H plus V1 square minus by 2Z is equal to small h plus capital H. And that is V1 equals to root over 2GH. This is the theoretical value and the actual velocity is equal to CV root 2GH. Here CV is the coefficient of Pitot. And Applications. There are a wide range of applications in the Pitot Tube. It is used to measure speed of an aircraft, used to measure speed of a boat, used to measure fluid flows in different industries, used to measure flow profile in a duct or channel, and it can be used where very high accuracy is not required. In general, phytotube is used to measure velocity of flow. And advantages of phytotube. It has no moving parts, which helps in minimizing frictional losses. It is small in size and low in cost, causes very less pressure loss. Due to its small size, it can introduce to fluid flow without shutting down the flow. As there are advantages, we can definitely have disadvantages in a parallel way. And these are the disadvantages. Any foreign material inflow can change the accurate reading. Its accuracy is not that good and has low rangeability, low sensitivity, and works better in high velocity flow. A change in velocity profile can cause significant changes in readings. It can be used with dirty fluids. Its sensitivity gets disturbed by flow direction. Thank you.